An empirical formula, when you look at that word, I want you to think of the simplest ratio. So in your notes, I want you to highlight or circle the word simplest. And anytime you see empirical, you need to think simplest ratio. So basically, this is a formula that shows the smallest whole number ratio of elements. And we've talked about the fact that for ionic compounds, it'll always be the simplest ratio. But for covalent, it's not necessarily empirical every time. An example of empirical formula would just be CH, because you have one C and one H, that's as simple as you can get. The molecular formula is the actual formula itself, so highlight or circle the word actual. So when you look at these vocab words, for empirical, think simplest, for molecular, think actual. So the actual formula is not necessarily always the simplest ratio. For ionic compounds it will be, but for molecular compounds it's not necessarily the simplest. For example, if you have C6H6, you can simplify this, but in real life this is benzene, and it has 6 carbons and 6 hydrogens in the molecule. So this is called the molecular formula, and this would be the empirical formula. So today we're going to learn how to calculate each of these, and the calculations are not difficult, it's just several steps and you have to know what step to do next. So you want to make sure you spend some time practicing it so that you can memorize what steps to do next and you know exactly how to do it. So for empirical formulas, the first step is that you want to convert grams to moles. What we're looking for is the subscripts that go in the formula, and those subscripts are in units of moles. So we're given 0.9 grams of calcium and 1.6 grams of chlorine. The first step is just to do what we've been doing for several days now and turn it into moles. So bring grams down. This number came from the periodic table because every time you see grams you need to think periodic table. Same thing for chlorine. So bring your grams down, plug in the number from the periodic table, and you get a number. Now in this case, let me just make a note that this is chlorine. When it's by itself, you always put a 2 on it. You do not multiply this mass by 2 though, because chlorine is not by itself. Chlorine in this case is bonded to calcium. We just don't know how, but we know that they're bonded together somehow. So in this case, it's not a Hofbrinkel, and you're not going to multiply this by 2. Once you get your 2 moles, you're kind of done because you have the mole-to-mole ratio. So you could say that calcium, the subscript is 0.0224, and for chlorine the subscript is 0.0451. But scientists don't want to see these long decimals as subscripts, they want nice, neat, little pretty whole numbers. So your next job is to get these into whole numbers, and the easiest way to do that is to choose the smallest number that you have and divide that into everything. Because if you divide 0.0224 by 0.0224, you're going to get 1. So that at least fixes this one, and a lot of times it'll fix the other one as well. So step 2 is to take the number of moles of each thing and divide by the smallest number that you got. And notice in this case, it works. So you got 1 for calcium, this is close enough to 2 to round it, so 2 chlorines, so this is the final answer. Your empirical formula is that you have 1 calcium for every 2 chlorines. Sometimes when you divide by the smallest, you'll get a number that's not close enough to round. So if you get a number that ends in 0.5, 0.33, or 0.25, those are not close enough to round to the nearest whole number, so you have to multiply to make them whole. So 0.5, since that's a 1/2 fraction, you can multiply it by 2 to make it whole. 0.33 you can multiply by 3, and 0.25 you can multiply by 4. So these are the fractions that I want you to watch for. Don't multiply these fractions by these numbers until you divide by the smallest though. A lot of people for some reason skip step 2 and go directly to step 3 and then they get the wrong answer. Alright, so let's do another one and I'll show you what I meant by multiplying those fractions. So first of all, a lot of times you'll be given percentages instead of grams. So you can choose any amount of grams and you're just going to take 66% of it. But if you choose 100 grams, 66% of 100 is 66. So basically it just keeps you from having to do a calculation. So if you assume that you have 100 grams, you can just replace the percent with grams. So the first step, just like we did on the last one, is to turn it into moles. Calcium was 66 grams. This number came from the periodic table, and you get 1.646 moles of calcium. Phosphorus, turn the percent to grams, divide it by what you have on the periodic table, and you should get 1.097. The second step, don't round it right here. Don't ever round it at this step. The second step is that you have to divide by the smallest. So of these two, 1.097 is smaller. So divide that into both of your numbers. And notice that it fixed phosphorus because now you have a 1. And it didn't quite fix calcium. So 1.5 is not close enough to round. At this step, it needs to be either 0.9 or 0.1 for you to round up or down. But if it's in the middle, if it's anywhere between 0.1 and 0.9, you're going to have to multiply it. So this is the case where we need to multiply the 1.5 by something to make it whole. And since 0.5 is the fraction 1/2, we can multiply this by 2 to make it whole. But keep in mind that these two are ratios, so if you do this one by 2, you also have to do phosphorus by 2 as well. So this is the case where you have that third step. 1.5 times 2 gives you 3, but you also have to multiply phosphorus by 2. So your final answer here is Ca3P2. This is the empirical formula. It's the simplest ratio. And I want you to stop right here for a few minutes and try some on worksheet number 9 and check your answers and make sure that you're getting this before you move on, because it's important you understand how to do this before I teach you molecular. For molecular formulas, what you're trying to find out is the actual compound, which is not necessarily the simplest ratio. And to do this, you need two pieces of information. You need the molecular mass, which is the mass of the actual compound itself, and you also need the empirical formula. Sometimes I might give you the empirical formula in the question like I did here, but you can now solve for the empirical formula doing what we just finished doing. So you may have to calculate that first, or I might give it to you. And basically what we want to do is compare the simplest formula to the actual. But you can't compare a formula to a number, so the first thing is to add up the mass of the simplest so that we have two numbers. So you have 1 carbon, 2 hydrogens, and 1 oxygen. Use the masses on the periodic table and you should get 30. And you can probably see that the real compound is 180, the simplest is 30. The real compound is going to be some multiple of the simplest, and you can probably do that in your head. So you're going to divide 180 by 30 and you should get 6, which means that the real compound is 6 times as big as the small one. So then all you have to do is multiply your subscripts by this factor. So our original empirical formula was C1H2O1, so if you multiply 1, 2, and 1 by 6, you get C6H12O6. So this is our molecular formula. It's not empirical because it's not simplified, it's called the molecular. So again, to do that, all you have to do is take the mass of the simplest, divide it into the real mass, and you'll get a number, and that's the number you multiply all your subscripts by. Here's another example. I want you to pause the video and try it yourself and then check your answers. Step 1 is adding up the mass of the simplest compound. So 1 carbon, 3 hydrogens, and 1 oxygen should give you 31. 31 goes into 62 exactly twice, which means the real compound is twice what the simplest one is. So you're going to multiply all of your subscripts by 2 and you end up with C2H6O2. And this is the last question, and this tests everything that I just taught you. So if you're doing this for the first time, go ahead and pause the video, and I want you to try all of this by yourself. Take a few minutes to work both the empirical and the molecular formulas, and then I'll put the answers up for you. And if you've already done this in class, you can try some on worksheets 10, that's the molecular one, or 9, which is empirical. So worksheets 9 and 10 follow this lesson. Once you've finished this, you can check your answers. You should have gotten 4.9 moles, 9.8 moles, and 1.96 moles. Do not round these numbers. This is not the step where you round it. The next step is to divide by the smallest, and you should get 2.5, 5, and 1. 2.5 is not close enough to round, so then you need to multiply it by 2 to make it whole, but don't forget to do that for all of your numbers. So 2.5 times 2, 5 times 2, and 1 times 2, and you end up with C5H10O2. This is your empirical formula because it's as simple as it can get. There's no number that'll go into 5, 2, and 10. Then what you're going to do is take your empirical formula and add up the mass of that. And you should get 102, which goes into the real formula, exactly twice, because the molecular mass was 204, the simplest mass was 102. So divide that and you should get 2, which tells you that the real formula is twice what the simplest was. So multiply all your subscripts by 2. And your final answer there is C10H20O4. And that's it. So worksheets 9 and 10 follow this lesson, but that's all for today.